And we are recording. Okay, so this week's decimals lesson is all about dividing decimals, which is not new. We were already doing that in last week's lesson. But the main focus of this week's lesson is going to be dividing with decimals while solving word problems. So we're sort of covering two things at once because knowing how to handle word problems is its own challenge for math students. And I'll talk about strategies for doing that. But I'm going to start just with some straight dividing these two divisions without any word problem being involved, just as a review. Make sure people remember what we were doing last week. So I'm not doing one of the super easy ones. We have 77 divided by 3.5. The number that's being divided by has a decimal. So how do we set that up when we do it with pencil and paper? We write 77 and we put 3.5 in this position, and I'm making this roomy because we have to adjust the decimal. When you're dividing with decimals and this has a decimal, we have to move it. It's too confusing to try to do it if we don't move the decimal. So I'm multiplying the 3.5 by 10. In other words, I am jumping the decimal one spot to the right. But that means I have to know where the decimal is in this number, and I have to also jump that one spot to the right, which means I'm putting a 0 in here, and my decimal ends up there. And the decimal that matters to me the most is the one that I put up on top for the answer, that is in the right position. Okay, and then I'm asking myself, okay, this is now a 35. 35 doesn't fit into 7, but it does fit into 77. So how many times does 35 fit into 77? I'm going to put the answer right above this second 7. 35 times 2 is 70, so I can put a 2 here. 2 times 35 is 70. I subtract, that leaves a 7 here, and then this 0 I have to carry down. Then, how many times does 35 fit into this 70? Well, twice, of course. And therefore I put a 2 here. We notice how we are lining the numbers up and lining the decimals up, otherwise we will end up with a mistake. And 2 times 35 is 70. I subtract, I get 0, which means I know I'm finished. Now, of course, getting a 0 doesn't always happen when you're dividing with decimals, but it is convenient when it does because it means that we have our answer. Our answer is 22. The decimal's right there. I can put a 0 here if I want. I can write the answer as 22.0 or just 22. Either way, it is the right answer. That's just a review. Okay, so now let's do this one. Slightly more challenging, perhaps. Let's try it. We're going to write the 72.42 here. And then we're going to build our little loop thing here and put 1.7 in it, but this 1.7 has a decimal that has to be adjusted. I am jumping that decimal one place to the right. That means this one has to go one place to the right, and therefore the decimal in my answer will be right above that. So the little arrows might make it look a little cluttered, but it's a way of showing what you're doing and being organized so that you don't make a mistake. Getting decimals into the right position is crucial when we're doing this. And now we're not dividing 72.42 by 1.7 anymore. We're now dividing 724.2 divided by 17. And that is a little bit more straightforward. 17, of course, does not fit into 7, but it will fit into 72. How many times? So 17 times 4 is 68. That's going to work. So I'm going to put a 4 here. 4 times 17, 68. Subtract. 72 minus 68 leaves this 4, and then this 4 I will carry down. 17 fits into 44. How many times? Is it 2 or 3 times? I think it's just 2. 2 times 17 is 34. Write the 2 there. Subtract, and I have 10. So I didn't end up losing a digit there. I still have 10, but of course 17 doesn't fit into 10. And I'm going to carry this 2 down. I want to make sure this is fitting on the video rectangle, and it's fitting okay because I'm not finished. How many times does 17 fit into 102? Let's try 5. 5 times 17 is 50, 85. No, I think I might be able to do one more. Yes, 6 times 17. 6 times 10 is 60. 6 times 7 is 42. 60 plus 42 is 102. We're right on. So we have a 6. 6 times 17 is 102. Even though I know I'm finished, I still want to show what I'm doing and show the subtraction and not 0. My answer is 42.6. So this one didn't keep on going on forever. And we got a nice clean answer. 42.6 is a clean answer when you are judging dividing with decimals. This is pretty good, and of course this is just a review. I am just going to quickly check my chat and say hello to anyone who's arrived. So yes, I have had people arrive. Hello you people, you are welcome of course. You know what I'm doing. I'm making a video and I am teaching at the same time. So those were just reviews of dividing with decimals that were not word problems. Now I'm going to start putting up some word problems where we're going to exercise the same mathematical muscles. So first, erase. And of course, word problems are always a bit of a challenge when you're trying to do an online class or even make a video, because it takes time to write the word problem, especially when you have to write it on a chalkboard. Kind of slows me down, but the thing is, word problems are important. We have to deal with them, so we're just going to have to do that. So I'm writing my word problems, but I'm not writing very big paragraphs. I'm trying to keep them fairly simple to read, fast to read. Take a quick look at the time. How am I doing for time? Okay, we need, let me see, where will I write this? We need $46.75 for some reason, and we have 55 oranges. Yes, fruit and vegetables will be a theme of my word problems occasionally. But I'm not finished. I have to ask the question. How much must we charge per orange? Now, this is a good question to me, one that I'm actually going to find a way to do this twice, 2 different ways. And it's just so we can examine the division of decimals and how we apply the steps and what happens in a word problem and how it makes you do different steps in your divisions. So right now, what we're doing is we're taking 46.75 and we're dividing it by 55. And the 55 doesn't have a decimal in it. So that is fairly straightforward. 46.75 divided by 55. I don't have to jump the decimal in this one. Put that down. And I'm going to go over all the steps, of course, and not try to go too quickly. So the decimal, therefore, is in the right place, and I can put this decimal up here in my answer. Now, 55 doesn't fit into 4, so I'm not writing a digit up here above the 4. 55 doesn't fit into 46 either, so I'm not writing a digit, or if I want, I can put a 0 here. But 55 does fit into 467. How many times? Okay, that does sound a little confusing. Are we going to do this in our head? I do like doing it in my head, but of course there are different strategies. And one of the strategies, where is my calculator, is a way to use a calculator. Ironically, when you are proving that you can do some complicated math without a calculator, you still might find yourself using a calculator along the way. Okay, so how many times does 55 fit into 467? I can just say 467 divided by 55, and I'm getting 8.49090909. I'm getting a long decimal, but I don't really care about all of the decimal digits. When I see 8.490, it's that 8 that matters to me. It means it fits more than 8 times. So therefore, it will fit 8 times. 55 will fit 8 times into 467. And since I went all the way to using 467, that means that the 8 has to be written right here above the 7. 8 times 55, that I can do in my head. 8 times 50 is 400. 8 times 5 is 40, so the total is 440. And we subtract. And when we do the subtraction, we end up with 27. And of course, 55 doesn't fit into 27, but I still have this 5, which I will carry down. 55 does fit into 275. How many times? It might be right on 5 exact times. 55 times 5. It is. Okay, so therefore the 5 goes there. 5 times 55 is 275. I know I'm finished, but I still show the final steps. We get that 0, we know we're finished. The answer to the question, therefore, is, I want to see if this is going to fit for me to do it again. I think I'll manage to fit it. So I'm going to write the answer below. It's going to be 85 cents per orange. Now remember, it's a word problem, so you give your answer with a unit of measure, and there's actually a dollars per orange unit of measure here when you think about it, because we're asking how much does each orange cost. So it's the cost per orange, and the slash is useful. Okay, so I was able to do that, and it wasn't really that complicated. It involved money. Decimals and money are very intertwined. It's important to be able to handle decimals when you deal with money, but it's also an advantage that a lot of students find decimals easy and they like them a lot because they're already used to handling money. So, will it always be this way? Will we never, when we're doing a word problem that involves money like this, where we divide decimals, will we never have to move that decimal, jump the decimal place? Well, depends on how the question's asked, and that's why I like trying to do this in another way. Right beside, I'm not going to erase a squiggly line. I have to make sure that it fits though. What if I asked a different problem though? What if I were to say, well, we need $46.75 and we want to charge 85 cents per orange. How many oranges will we need to sell? So it's really the same sort of situation, and we already know the answer. We know the answer is going to be 55. When we really think about it, we kind of know all three numbers now because we did this. But what if we didn't? What if we hadn't already done this division, and we knew that we needed 46.75, and we knew we had to charge 85 cents per orange? How many oranges would we need? How would we find that 55? So let's show what that will look like. I'm going to put the 46.75 here. I need that loop, and I'm making it nice and big so I have room to show everything, and I'm trying to make sure it'll show well on the, well, it'll show adequately on the video rectangle. And I don't need this calculator in my hand, so I'm putting it down. $46.75 divided by 85 cents. Now I have to show my decimal here. Okay, now, just because I changed the problem just in that little way, now we are dividing by a number that has a decimal. And we have to jump the decimal, so we can correct that, which means we're going to move the decimal 2 places to the right, and that means this decimal has to move 2 places to the right. It ends up there, and that shows me where I need to put my decimal for my answer. Very important step. But now what we're doing is 4,675 divided by 85. An old-fashioned division that doesn't have decimals in it. That's convenient. But of course this decimal is still ready for our answer, and we see what happens. 85 doesn't fit into 4, so I'm not writing a number here. 85 doesn't fit into 46 either, so I'm not writing a digit here. But 85 will fit into 467. How many times? Will it fit 5 times? Let's think. 5 times 85 is 425. Yes, it will. So I'm putting a 5 here. 5 times 85 is 425. I subtract. Subtracting, I am left with 42 here, but this 5 carries down, so I have 425. Oh, well, this is convenient, because I just figured out that 5 times 85 is 425, and all I have left here is 425. So that means I'm going to put another 5. 5 times 85, 425. Subtract, I get 0. I know I'm finished. And my answer is 55 oranges. And of course, I can write the decimal, or not. I can write 55.0 oranges if I really want, but I didn't need to show decimal digits to the right of that decimal, not with this question. The interesting thing about doing this twice is simply to compare what happens with the division and which steps we have to apply. I heard a noise. Students, if you are sending me a message, do it in the chat, please. And I'm just double checking also to see who's there and saying hello to everyone. And hello to all of you. Okay, so 55 oranges is the answer if we are dividing the amount we need by the cost per orange that we want to charge. 85 cents is the answer if we are dividing the amount we need by the number of oranges we know we have. One of them puts us in a position where we have to move the decimal place to do our division, and the other one doesn't. That's what I'm comparing. It's just one of those what ifs. Okay, so let's move on to another word problem. And I'm not going to do this one twice. At least I don't think so. Let's see what I have prepared here. Nope. But it's another one where we're going to be using money, and it's not going to be oranges, avocados this time. Okay, so Doug's going to do a word problem involving avocados. And of course, the longest part is writing out the word problem. So let's get into that. Okay. How much must I charge per avocado if we need $43? And we have 47 avocados. And we may as well talk a little bit about the strategies for word problems. Because what are you being asked to do when you answer a word problem? You're being asked to do the math that you've been practicing, but instead of being given the numbers and asked to do an operation, you're given a situation. And what you're really being asked to do as far as extra work is translating from English into math, from English language into math language. We want some sort of an equation that we can figure out, but we have mostly words, just a few numbers. Sometimes the numbers are even written out as words, and this is what is being tested. We have to be able to figure out what operation we're doing when we are doing a division here. So what am I going to do in this case? I'm going to divide $43 by 47, and that's going to look like this. Ooh, more chalk, please. And I don't have to jump a decimal to do this one. So it's another one of those easy ones. Or is it going to turn out to be easy? Chart price per avocado. We're going to find out. So the decimal here is here. And that means the decimal in my answer is going to be right above it. And I don't have to do that extra step. So let's get into it though. But the thing is, of course, 47 doesn't fit into 4. So I'm not writing a digit above the 4. And 47 doesn't fit into 43 either. So I'm not writing a digit above the 3. Unless I want to put a 0 there. But after the decimal, that's where I'm going to have to write something. So what I have to do is I have to show a 0 after the decimal in this number. Because 47 won't fit into 43. So I have to use 430. How many times does 47 fit into 430? Is it 8 or is it 9? I can use my calculator to play around with that and figure it out. 430 divided by 47. 9.1, so it fits 9 times and more. So I'm putting a 9 here above the 0. Then 9 times 47 is 423. I'm getting into my division. I do my subtraction, that leaves 7. And then 47 doesn't fit into 7, but I don't really have a complete answer, do I? I don't want to say 0.9. I need to keep going. So that's what's interesting about this. It looked the same as one of the others that was quite easy, but we don't want to say 0.9 when we're giving an answer about how much to charge per avocado. It's not accurate enough. There would be 90 cents or what, 90 something cents. Well, 90 what? How many cents? We have to keep going. So therefore, I'm going to have to put another 0 here and carry that 0 down. I'm going to make this line longer. And 47 does fit into 70, but only once, so I'm going to put a 1 here. 1 times 47 is 47. Subtract. 70 minus 47 is 23. And it sounds like my answer is 91 cents, but again, I'm asking myself, wait, should I keep going? The division shows that I can keep going. But do I have to keep going in order to answer the question? And I realize, well, yes, because it's 91 cents. The answer is going to be very close to 91 cents, but we know that there's actually going to be another digit here. And what digit happens here is going to impact whether we're rounding up or rounding down. We need to keep going so that we know what we really have. So I'm putting yet another 0, carrying down yet another 0, and I now have 230. 47 didn't fit into 23, but it fits into 230. Is it 5 times? 5 times 47. No, it doesn't fit 5 times because 5 times 47 is 235. So I have to do it 4 times. 4 times 47, yes, I can do that in my head, but I'm not going to show off right now. That's 188. Subtract 230 minus 188 is 42. Now that means I can keep going. As far as the decimal division is concerned, I can keep going and I can get a more and more accurate answer. But do I need a more accurate answer? Let's remember what situation we're in. We're trying to figure out how much we must charge per avocado. And money, we round money to the nearest hundredth, the nearest penny. Whether we're using pennies or not, we round it to the nearest penny. So therefore, I've gone far enough. I've gone past the nearest hundredth, even to the thousandth. And I know enough to say, well, this decimal, 0.914, if I round it to the nearest hundredth, is going to be 0.91. It's rounding to 91 cents. But wait, does that make sense for giving a complete answer to this question? And no, it doesn't. Because normal rounding rules are when the digit after this one is a 4, that means we don't round up, so it stays a 1, so we have 91 cents. That's the normal rounding rules. But this situation was, we need $43. And if we don't round this up, will we come short of the amount of money we need? Well, we can find out simply by multiplying. So the 91 cents that we think might be our answer, we can try multiplying that by the 47 avocados we have. And here I am doing multiplication of decimals again. Of course, multiplication of decimals is extremely useful while you're learning division of decimals because you verify a division with a multiplication. So let's just quickly do that. I know the students know the rules. I have got the digits lined up. It's a multiplication. I don't put the decimal in the answer yet. I have to figure out where it goes by counting decimal digits. 1 times 7 is 7. 1 times 4 is 4. Then because I'm moving on to this 9, I have to put a 0 here. 9 times 7 is 63, so I put the 3 and carry the 6. 9 times 4 is 36, plus the 6 I carried is 42. So I can write all of that. Then I'm adding these, and I have 4, 2, 7, 7, but I have 2 decimal digits. So I have to have 2 digits to the right of decimal in my answer. And what I'm getting is, if I charge 91 cents per avocado, and I sell 47 avocados, I will end up with $42.77, which is not enough. Because of that, I have to round up to 92 cents. And if I charge 92 cents per avocado, I will have enough. I'll make a little more than $43. How much more? Well, we can find out. Let's do it by doing multiplication. So now I'm doing 92 cents, multiplying it by 47. We line it up like a multiplication. 2 times 7 is 14. There's the 4, carry the 1. 2 times 4 is 8 plus the 1 I carried. That's a 9. And then I put the 0 here. 9 times 7 is 63. There's the 3. Here's my 6. 9 times 4 is 36 plus the 6 I carried is 42. Add these together. 4, 2, carry the 1. There's 3. I have $43.24, which is more than $43 that I needed. So now I know that this is the right answer. 92 cents per avocado is the amount to charge. And then, of course, we have the next factor to worry about, which is when you're selling avocados for 92 cents each, is the fact that it's 92 cents too inconvenient for the person who's selling and making change, and for the person who's buying, who might have to start scrambling around looking for pennies, that sort of thing. So we could even choose to round this all the way up to 95 cents. Because 95 cents means we don't have to deal with pennies. And what's going to happen, and I'm not going to do a third multiplication, what's going to happen is that the person's going to make even more money. Rounding it up another 3 cents to 95 cents means that we're going to make we're definitely going to exceed the total we needed, the $43 we needed. Interesting how I can get so much depth into my answer when I'm answering this word problem if I think about it as if it were a real situation. Because the real situations do inspire the word problems. I'm going to take a quick look at my chat. Just make sure no one's asking me any burning questions. And see who's here. A bunch of very good students are here, of course. And how am I doing for time? I'm doing quite well for time. I got to the end of my first page of my lesson plan, and that's about half of my lesson plan. And it took just about half of the time I was planning to take. So I think I'm safe to keep going. I'm going to keep going. That's good. And of course, the next thing I have to do is erase and write down another word problem. The slow part is the writing. Okay, that was an interesting situation though. And it was interesting seeing what happened with the math, where when we first saw the problem, we didn't really have to do any of the extra steps that involved dividing with decimals. But then when we were choosing how to answer the question, we gave ourselves quite a few extra steps in order to make sure that our answer was the best answer possible. I like that. Okay. Trying to get a chalk container that has a good sized piece of chalk in it so that it won't run out halfway through the next question. Okay, so finally that's something that doesn't involve fruit or vegetables. Or money. Do all decimal word problems always have to involve money? No. Money definitely forces you to deal with decimals. So that's convenient when you're going to make up problems that you hope will make students practice their work with decimals. But there are other types of problems, and here's one. I have a ribbon. I have to confess I come from a crafty household. My wife Bunny makes crafts and she uses ribbon quite a lot. I have a ribbon 85.75 inches long. And I need pieces, oh, that's a comment. And I need pieces three and a half inches long. Oh, 3.5 inches long. What's the question? How many will I get? How many pieces will I get? Okay, good question. So it's not money, but it still is decimals. We are taking an 85.75 inch piece of ribbon and we are dividing it by 3.5. So our decimal division is going to look like this. That's a little messy, that 3. Let me do it again there. And the number that we are dividing by has a decimal in it. So I have to move that decimal, I have to jump that decimal one spot to the right, which means that this decimal also jumps one spot to the right. We are correcting both numbers by multiplying both of them by 10, basically. And so long as you do that to both numbers, it means that your answer will fit this new version of the problem, but the answer will also fit the original version of the problem. We are going to get the right answer. Okay, so that decimal moved over there, which means the decimal answer is up here, and now we can get into our decimal division steps. And of course, that's the fun part. We are dividing by 35 now. 35 does not fit into 8. And it does fit into 85. How many times 2. 2 times 35 is 70. I subtract. That leaves 15 here, but of course 35 doesn't fit into 15, so I have to drag down the 7. 35 fits into 157. How many times? Does it fit 5 times? No, it'll fit 4 times. So how did I decide that it wouldn't fit 5 times? 5 times is 35, 5 times 30 is 150, 5 times 5 is 25, 150 plus 25 is 175. That's way bigger, it's too big. So I need 4. 4 times 35 is 140. And yes, use calculator as necessary. Subtract, we have 17. And 35 doesn't fit into 17. But we're not finished. We didn't get a 0. So I am going to carry down, oh, and I still have this digit here. Of course I'm not finished. I have to use this digit. So I'm carrying this 5 all the way down. Does 35 fit into 175? And you know what? We were just talking about 5 times 35. And it was 175, wasn't it? Yes, it was. So a 5 goes here. 5 times 35 is 175. We subtract. We get a 0. We got lucky. We got that 0, so we know we're finished. We don't have to worry about how much further should I go. We know that we can stop. 24.5 is my answer. And the unit is going to be pieces. But of course, to be as clear as possible, I should write pieces of ribbon so that people don't say pieces of what? Okay, 24.5. But wait, what's 0.5 piece of ribbon? I mean, we need a 3.5-inch long pieces of ribbon. If we have a 0.5 of one of those, it means we have a piece of ribbon that's too short. So I actually end up having to round, and I'll do it like this. I put a comma and I say, therefore, 24 pieces of ribbon. And yes, I'm being fussy and I'm writing it all out, whole word thing, not just pieces of ribbon. So I actually ended up with 24 pieces of ribbon as a more sensible answer to this question, because that extra half a piece of ribbon isn't long enough, so it may be useless, or it may go into a drawer as a scrap to be used later. It's interesting to try and find uses for small scraps when you are doing crafts and you have leftovers. But notice how normally the rounding rules have us round 24.5 would round up to 25. But we can't say we have 25 pieces of ribbon because one of them wasn't long enough. So we have to round down. We have to break the normal rules of rounding and round in a way that matches the situation. And that means there's a little more to this than there is when you just do the straight math. The word problem puts you in a position where you have to think a little bit more, and sometimes you have to apply certain types of common sense like that in order to come up with the best answer. That was fun. You take a quick look. I heard a little bingy bongy sound. So that probably just means I received an email. But I'm going to see what it is. Aha. It's an interesting looking email, but unfortunately it's an email that includes a video, and I am not playing a video right now while I'm recording a video. Okay, so that will have to wait. How am I doing for time? Do I have any questions in my chat? I don't see any questions in my chat, so I'm good. Okay, I want to do another word problem. Let's see. Some of these eraser cloths are getting a little dusty. This one seems fairly clean. Let me use it. I like that problem. I liked the way it made us think about how we're rounding our answer. And now, what's my next one? How much juice per jug if we have 113.95 liters and 43 jugs? We're back to, well, it's not, I can say it's not fruit and vegetables, but yes it is. It's juice. So it's some type of juice. Maybe it's orange juice from the oranges from before. Maybe it's avocado juice from the avocados from before. Avocado juice, that sounds good. Okay, I'm gonna write the problem now. How much juice per jug if we have, what was that number? 113.95. What's that? 95 liters of juice. I'll put a comma. And 43 jugs. question mark. Okay, now I admit, normally I would use a few more words and make this word problem a little bit more grammatical. But because I'm writing it out on the chalkboard and trying not to take too much time to do it, I end up doing a little bit shorthandy and abbreviation-y. Okay, how much juice per jug if we have 100? We're dividing again, and there's no money, but there's still decimals. And oh, we have switched over into the metric system. We were doing inches before because, of course, craft supplies like ribbon, very often you're going to find yourself using the standard system, the imperial system with inches. But sometimes you have the metric system. So we don't care. We're math students. We can handle the metric system. We can handle any system. But we have to handle the division right now. And it's 113.95 divided by 43. No, I didn't leave enough room. There, 113.95 divided by 43. And it's yet another one of those situations where this doesn't have a decimal. We don't have to jump the decimal, which means in our answer, the decimal will be right here above that one. Well, that kind of simplifies that step a little bit. So let's get into our division. Just take a quick look at, make sure everything's okay. Okay, 43 doesn't fit into 1. No kidding. 43 does not fit into 11 either, so I'm not writing digits here or here. But 43 will fit into 113, I believe, 2 times. 2 times 43 is 86. Then we subtract. Now, I'm not showing all my steps with the subtraction. I admit it. Subtracting decimals is a thing that we were covering not that long ago, but I'm trying to go quickly. So 86 from 113, that's going to be 27. Of course, 43 is not going to fit into the 27, so I'm carrying down this 9. And 43 will fit into 279. How many times? 6 times? 240. I think that's going to be it. 7 times 280. No, it won't fit 7 times. It will just fit 6 times. I'm putting a 6 here. 6 times 43. 6 times 40 is 240. 6 times 3 is 18. 240 plus 18 is 258. 9 minus 8 is 1. 7 minus 5 is 2. We have 21 left. We're not finished. It's not a 0. And of course, 43 won't fit into 21. And we still have this 5, which needs to be carried down. 43 will fit into 215. How many times? Will it fit 5 times? Ooh, 5 times 43 is going to be exactly 215, isn't it? 5 times, excuse me, 5 times 40 is 200. 5 times 3 is 15, yes. So 215, subtract. Got a 0. I got one of those nice ones where I ended up with 0, so it means I know I'm finished. But of course, I should have written this 5 before. 5 times 43 is 215. That's what I did. Okay, so 2.65 is my answer. We're able to fit 2.65 liters of juice in each jug. So is my answer complete? No. A lot of students would really want to stop there, but I'm fussy. It's not liters, it's liters per jug. Because that's really saying what the answer is. We will put 2.65 liters in each jug. That's an interesting question. I kind of like that. And it went rather easily. Good. I hope the students are finding it easy. I'm getting there. I only have a couple more problems that are suggested in my lesson plan here. I need some juice. I'm standing too close to this chalkboard and I'm talking too much and I forgot to bring a can of fizzy water. And I'm not going to get one now because I'm nearly at the end of this lesson plan that I wanted to record. So, a piece of wire. We're getting crafty again. The type of crafts I do, I use wire sometimes. A piece of wire, 156.6 inches in length. Must be cut into 36 equal pieces. How long will the pieces be? That's right, eh? Yes. How long will they be? Yes, I should have written how long will the pieces be, but I'm just going to write how long will they be. Okay, so it's another division. And it's a decimal here, but we're dividing by 36. So again, we got one that we didn't have to divide by a decimal, but it's still decimal division. Make sure I copied that number correctly. Here's my 36. I don't have to adjust the position of the decimal for this one. So therefore, the decimal in here, the decimal in my answer is going to be right above it. Okay, 36 doesn't fit into 1. 36 doesn't fit into 15. But yes, 36 will fit into 156. How many times? I don't think it's going to fit 5 times. Nope, 4 times. 4 times 36, that's 72 times 2, 144. Subtracting, that's 2. That's 1, and then I have to carry down this 6. Okay, 36 fits into 126 how many times? I'm sure it'll fit 3 times, but I don't think, no, it's not going to fit 4 times. So I'm putting a 3. 3 times 36, that's 90 plus 18, that's 108. Okay, so this is going very cleanly, except that I'm not getting a 0 when I do the subtraction. That's leaving 18. Should I keep going? Yes. How long will they be? Well, 4.3 inches in length is my answer so far, but since I didn't get a 0 here, it's not exactly 4.3, and I want to see what's going to happen in terms of rounding, etc. And can I give an answer that's perfectly accurate, or do I have to round? Depends on the situation. So I need to put a 0 here. I'm going to make this line longer, and I'm going to carry that 0 down, and now I have 180. And I think we might be lucky here, because 5 times 36, I believe, is exactly 180. Yes, it is. So I'm putting my 5. 5 times 36 is 180. Subtracting, getting a 0, so I know I'm done. I have a perfect answer. 4.35 inches are the length of the 36 equal pieces I'm going to get from this wire. Interesting. So we didn't have much decimally stuff to do at the beginning, but then as we carried on, we ended up having to do some of the decimally stuff. Basically, if we practice everything, then we don't care, because we know how to handle it. And if we think we might need more, if we didn't get a 0 and we're not sure if we're finished, well, we know the steps. So we just do the steps that we know, and eventually you're in a position where you either get an answer that's clear or you have to round. But don't stop too early, that's all. Okay, so that's it for that. And in fact, that's the last of my word problems, but I do have one more division that I'm going to do. Because the last time I did this lesson, I did finish, and I had time left, and there were students there, and I asked the students to suggest some decimal division problems. Now, when I did that last lesson, none of these questions were the same. To prepare this lesson today, I changed all of them. So we have oranges instead of apples, and avocados instead of grapefruits or something, I don't know. Everything changed, all the numbers changed, but this is one thing that didn't change. I am using a division that a student suggested without changing it, because if I changed it, it wouldn't be suggested by the student anymore. It would just be a question I made up. And I like it when students participate. So we have 73, taking a quick look at chat and making sure everything's okay. 73 divided by 45.90. And I really liked this question. That's why I wanted to use it when that student suggested it. There are two things I like about it. One thing is that a lot of my word problems, we were getting a little too lucky. The number after the divided by sign kept on not having a decimal in it, so we weren't having to adjust the position of the decimal often enough. And it's one of the things we have to be able to do, so I want to make sure the students practice it. This time we're going to have to do it because there's a decimal here. The other thing that's interesting, I'm going to write it first. 73, and then I'll put this on. I'm going to leave some room. So I make this nice and big. The other thing is 90. There's a trailing 0 over here. There's a 0 at the end. Now if it were money, would make sense. If it was $45.90, you don't write that as 45.9. You would show the zero. But this isn't money. It's not a word problem. There's no situation here. So why did the student choose to put a zero there? Well, why not? The student can put a zero there if they want. Just like we can always put a zero at the end of any number that we write if we want. So long as we have a decimal, we can put a zero at the end and it doesn't change the number. And we can always put a zero at the beginning of any number, whether it has a decimal or not. 073 is still 73. So a zero is kind of interesting the way we use them as placeholders. So this zero is sort of holding a place that it doesn't need. So I'm not going to write it in here. I'm just going to write 45.9. Would that be enough with some students to make them freeze? It's like, wait, I have to put a zero there. Now what do I do? I don't think it would stop any of my students. But it's really not something that we should be worrying about. It's something that we should just know what to do. And we know what to do. So this is what we do. Okay, so it's 45.9 after all. But I have to adjust the position of that decimal, so I move it one spot to the right. I am jumping the decimal one place to the right. I'm multiplying by 10. That means this number, which does have a decimal, which would be right here, also has to have that move one place to the right, which means I have to write a zero here, and my decimal for my answer is going to be here. So yes, this was a good question suggested by a student because it put us in a position of having to do that. And we have these arrows in the way and decimals that are written in weird places. We just have to know what we're doing. We have to be organized. I could rewrite the whole problem if I want now. 459 is being divided into 730. And then I can show the decimal. See, it's nice and clean this way. But I didn't want to do that. I do it sometimes. But I don't want to always do it because this is usually, I think, how people do it. They don't adjust the decimal and then write out the question over again. They adjust the decimal and then they get into doing their steps. So I like to be able to show that. So it's 459. It's an awful, big, confusing number. 459 is not going to fit into 7, so no digit here. 459 is not fitting into 73, so no digit here. But yes, 459 will fit into 730, but only one time. 1 times 459, gee, what's that? Yes, it's 459. Now I have to subtract. Even this is putting me in a position where I have to slow down and be careful because it's not so easy to do this one in my head. Is it 271? Well, one way for me to check is to take a look here because I actually calculated it before, and it is. Okay, so I managed to do that without making a mistake. Okay, 459 does not fit into 271, but I want to keep going. I don't want to say 1 point, I don't know, is my answer. I'm not finished. I might have to round to give this answer, but I don't want to start rounding yet. We're not there yet. We only gotten to the decimal in our answer. So what I need to do is put a 0 here, make this longer, carry that 0 down, and I'm trying to fit 459 into 2,710. Does it get any more challenging than this? 2,710 divided by 459 equals 5.904, blah, 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 blah. So it's the 5 that I care about. And now, 5 times 459, 2,295. So this student really put me in a position of wanting to grab my calculator. And I'm not finished because I'm not going to get a 0. 2710 minus 2295, 415. And certainly 459 does not fit into 415. I'm in a position where mathematically I have to keep going, but I still have to decide in terms of the situation, well, how far should I go before I round and give an answer? And what that means is if I'm making up this question and assigning it to students, I need to put an instruction where I'll tell the students, round your answer to the nearest this, round your answer to the nearest that, to stop students from torturing themselves and going all the way down to the floor in this calculation. But I don't really want to stop yet. Because let's say I ask the student round to the nearest 10th. Well, that's here, this is the nearest 10th, but we don't know if that 5 is going to round up to a 6 or stay a 5. unless we do one more step. So I'm doing one more step, and I'm going to give my answer rounded to the nearest tenth, and that means I need another 0, which gets carried down to here. I'll make this line longer. I'm making everything longer. Okay. And I'm doing, how many times does 459 fit into 4,150? And it is 9.04 blah, 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 blah. So it's 9. Now I'm able to give my answer. I'm still going to do the rest of the step that I started doing. 9 times 459 is 4131. I'll subtract. This one isn't so bad. It's going to just leave a 19 here. We still aren't finished, but I'm going to finish. Because I can say my answer is 1.6 if I round to the nearest tenth. If I'm rounding to the nearest hundredth, I would have to keep going because I don't know what comes after the 9 yet. But since I'm rounding to the nearest tenth, once I showed the tenth was a 5 and the number after it was a 9, that means I know the 5 is going to be bumped up to a 6. I round to 1.6, I have my answer. This has actually turned out to be a really fascinating, interesting question, which made me very impressed with the student who suggested it. Now, that is the last question that I'm doing for this lesson, so I'm going to stop recording this video and say, well, that was fun. Doing word problems is fun. You can't do as many of them in an hour as you can other types of problems. I could have done at least twice as many decimal divisions if I weren't writing out all the word problems. But is the word problem stopping us from being able to do the math? No, it isn't. So with that, I will say thank you very much, and I will see you next time.